What's up, YouTube? Welcome to this video on unit testing strategy. I want to cover the following in this video and in no particular order. I want to make a case for unit testing, and I'll explain what I mean by unit testing, but I want to make a case for that. I know a lot of you don't do that for any number of reasons. I want to make a case for what is generally understood as integration testing versus class level or testing classes in isolation. Generally using mocking, but there are many forms of the idea where you're testing every class in isolation. So I want to make a case for integration testing or testing the entire system. And I'm going to show you some code. This is code for my movie service, YouTube, repo on my GitHub. I've used this video as this code as an example for many other videos. It's been around on that repo for a few years now, but I want to use that code to explain certain things that when I talk about in this video by way of some slides. I'll use code to kind of correlate what I'm saying versus how it translates in code that might kind of gel in most people's minds. All right? If you come from the mocking world or testing class in isolation world, here's how it works for most of us. And this used to be me many years ago as well. We're introduced to something, right? So we take to it. Generally, we're introduced to things when we are younger. By younger, I mean just beginners in whatever that field is, whether it's younger in life or younger in terms of your first software job, etc. Right? Younger. In the early stages of our whatever it is we're trying to do. And then that becomes the de facto. Conversely, if you espouse the virtues of certain, let's say, a technology or technique, you should be doing that from a place where you bring to the fore, to the conversation, many other experiences with many other, let's say, competing techniques, so that you can truly be giving that sort of point of view and your opinion or your perspective on, as per your opinion and your experiences, given all these different ways to do something, this is what I think is the better one, right? Most people that have this argument about doing class level testing or testing in isolation have not tried anything else, or if they have, it's not been the right kind of the other thing. And by that, what I mean is, for example, there are many diets, and there's the ketogenic diet or the paleo diet, and there's 100 implementations of that. There's only one right one, which is what's there in the book, right? Let's say in paleo is in the Lauren Cordain's book. That's it. That's paleo. If you're doing something totally different from that or deviated from that, it's not paleo. And then if you have a bad experience with that diet, you can't say paleo is bad. That's what I mean, right? So it has to be good implementations or good. You need to get the benefit, except there's this other demerit to it. Right? So all of the techniques give you the merits that they talk about. They each have their own demerits, and you're really picking from which demerits you are not willing to live with. That's really what it is, right? And if those demerits are truly demerits of the technique, in this case. So if you come from that sort of background, I suggest please be open-minded, look at this or hear me out and try it out, definitely, and look at the movie source project that I'll put a link to in the show notes below. Look at it, go through it thoroughly. Spend some time with it. Then make up your mind. And if you have anything to say, I would love to hear your opinion, because for me, I'm not married to anything. I will flip on a dime if somebody says that's better than this. It takes me no time at all. So if you find that there's something wrong with what I'm doing, or these are all the problems with it, and I may not be aware of those, maybe I am, but in spite of those problems, I've chosen what I'm doing, as I said, compared to the other problems that I see elsewhere. So feel free to comment, give me your opinions on experienced only, and especially looking at my movie service project only, because that's the only one that I would say is like the true paleo, right? Everything else is not. So it's a very simple project, yet it has multiple technologies at play. So it exercises a good gamut of scenarios or test cases in terms of technique. All right. So starting with making a case for testing. We do test our software, do we not? I mean, no matter how you do it, whether you write tests or not, you're doing testing in some ways, right? So if you are, as you move through the paces, would you not like or prefer that all the past is being tested along with all the future stuff or present stuff? So that's one case for it, right? I mean, you are testing. And I know I've spoken to many people, when I'm talking at conferences or even at work. So, but we're not given the time. Nobody gives you time. This is your work. You don't say, I need extra time for testing. No, I need this much time to do the coding and the testing. That's your work. So rather than trying to say that people need to give you extra time for testing, you just need to ask for extra time to get the work done. We're caught between this thing of saying, listen, I'm a fast programmer, I do really good work, and I can deliver this to you in 2 days, You're not looking at testing. So then you're sort of making life miserable for yourselves. You need to, at all times, look at, when you're estimating, right? Whatever you estimate the work to be done, and I know this from my own experiences, plus experiences with people I work with today, and, for the last 15 years now. Generally speaking, when a developer says 3 days, it's 6 days. I mean, I just know. If you're telling me, as a dev on my team, and you're saying it's going to take me 3 days, I know it's going to take you 6 days. Because you haven't accounted for a few things, and you've certainly not accounted for testing. So I would say you need to start including the testing part in your estimations, first of all. And I'll make a case for testing in terms of what the values are. So you can probably take that back to your organization or the people, the powers that be, and see if you can convince them. So Ken Beck wrote this book on, TDD in 2000. Yeah. 22 years later, we're still debating two things. Should we be testing? And what the heck is TDD, or how do we do our testing? 22 years later, we still have these debates. We're still wondering if we should be doing a certain practice and how that practice should be practiced. It's amazing. I mean, we're just bad at communicating. We say things that don't make sense or they're not clear enough. Which is one of the reasons I have this programming with intent. Because when you write your code, you want to make sure your intent is super, super clear. There is no ambiguity in what you say and how you're saying it, what the intention might be, so that other people might interpret that something different. Anyway, so what is a unit? You say unit testing. So what is a unit? People, have, first of all, it starts right from there, the problem, or the confusion. What is a unit? Most people think a unit is the class. So when they say unit testing, you're saying, I'm testing a class. For other people, a unit is different. By the way, throughout this video, and anytime you hear me saying unit testing, I'm talking about using a unit testing framework in Visual Studio, for example, that allows you this means of automated testing. That's when I say unit tests, because there are a battery of tests and there's different kinds of tests, and I'll show you some of that. Or we'll talk about that. So for me, unit testing, it doesn't mean like the class level testing. It means using the unit testing framework in Visual Studio to have a suite of tests over a period of time that can run in an automated fashion, etc., etc. Right? That's what I say unit tests. But when you say unit test, what are you testing? That's what this slide is talking about. Now, Roy Osherove here. Roy Osherove has written a few books on unit testing and other related topics. he has actually changed his mind somewhat recently. I mean, I think I put a link to the video in the show notes below. They were having like a podcast of sorts, him and somebody else. Somebody else had basically invited him to the show. And I think today he's feeling comfortable in saying that he doesn't do mocking, but his books and his talks in the past have all been talking about mocking. Okay. But nonetheless, this is what he said way back, I think in 2001 or 2002 something. No, actually 2013. Whatever. A unit of work is any functional scenario in the system that contains logic. Any functional scenario. What does that mean? A unit of work is any functional scenario. Functional scenario is essentially a requirement, a business requirement. That's the term functional is used synonymously with business requirements. The functional scenario is a business requirements scenario. A unit of work is a scenario for a business requirement. That's a test. It can be as short as a function, or it can span multiple classes and functions. And it provides internal or business value to the system under test. And that is critical. Business value. Internal meaning there are some concerns that are technical concerns. The business couldn't have possibly told you about those things. And those technical concerns are internal value. Right? And then there's business concerns that mean they're more value to the business. Okay, now Ken Beck, who started this whole thing, at least he was the first one that wrote about and published that book in 2000, something to do with TDD. I'm not a big fan of TDD, by the way. Actually, we'll catch that up again next. I'll just finish the slide. He says, unit tests focus on functional requirements and scenarios. That's it. For a change, he actually spoke in very, very simple terms. I say that because if you read his book, he's like all over the place. All right. So, functional requirements. And that's all it is. Functional requirements and scenarios, which is, of course, every functional requirement has any number of scenarios. Right? Depending on the complexity of the requirement itself, you can have more or less scenarios. And every test method you write is a functional scenario. What Roy Osherove calls the unit of work, and so on and so forth. They're not talking about classes. They're not talking about dependencies or testing and isolation. They're saying here's a business requirement, and your test is a business requirement test and a scenario for that requirement. Right? And this was many, many years ago. They're still debating this whole thing, by the way. That's why I'm bringing it up. It's still under debate. No, that's not what it is. We are doing unit tests, doing testing classes and isolation and so on. All right. So the purpose of unit testing. First thing is to ensure an application fulfills the business and quality requirements for which it was designed. In other words, the confidence to deploy an application to production. So the one purpose is to ensure that the system you're building satisfies the business requirements. Not that all your classes are functional, but is the system going to work as per the requirement of the business? I mean, at the end of the day, that's really what we get paid to do. They don't care how we build the system and how many classes there are and how many unit tests we have that test every class. They want to know, does the system work? Right? And let's say, if you have to have tests that thoroughly test and ensure that the system works, why do you need class tests? You're just doubling up the work. And that's essentially what has happened to me over my lifetime or career, I guess, is I went from this unit level testing, class level testing classes in isolation to then having to write acceptance tests because that's what they wanted. That's what the business was going to look at. They don't care what you've done behind the scenes. They want to know that all these requirements, these scenarios have been tested and they output. They do what they're supposed to do. And then it came a point like, okay, first of all, why do double the tests? Right? Why are we killing ourselves writing twice the number of tests? Let's do it once, the acceptance test. And we got the most confidence from the acceptance tests, not from the unit test, from the class level testing. And so it was a bit of a shock, of course, as you can imagine. It's almost like somebody telling somebody to change their religion. But after over a few years, we realized that is it. I mean, the acceptance tests are all we need, because it's just how well you write the test, by the way. That's the difference. It's not about acceptance tests being good or bad. You have to write them well, first of all, which is why I keep saying that. You look at the movie service project, all right? And then compare that with something else you're doing. Don't compare just something you might have done in the past or whatever, because even what I'm doing today has evolved and matured. It's not like I went from testing classes and isolation to writing acceptance tests. I was an expert at writing isolation testing. I was not an expert at writing acceptance tests. I can't compare these two things, as if they're the same. They're not, because I was a novice at writing acceptance tests, but an expert at writing class testing and isolation. So if you're an expert at mocking or some form of isolation, testing and isolation, then compare my code in the movie service and tell me, and I'm happy to have a dialogue. I mean, I don't think there's a nirvana yet. And maybe we can find one, but it's not there yet, because there are flaws with everything you do. There are some demerits. It's all not all pros, right? We should be making our choices based on the demerits. What demerits are we willing to live with? What demerits are we willing to pay the price for? And I've chosen mine, right? The confidence to deploy to production, this is key many, many times. And there's some shifts going on in my organization as well that, that is gravitating towards writing acceptance tests and having those acceptance tests run on the build servers. And then basically when you're deployed, we have many environments before we get to production. And so the first environment you're deployed in, you can only deploy to the first environment if your tests have passed. And these are acceptance tests, not unit tests. We have unit tests. They're not helping, because with those unit tests and getting 100% code coverage or nearly 100% code coverage, and everyone thinking they've done the right amount of testing, by the time, even after getting to production, there are a bunch of issues, bunch of problems. So it's costing us a lot of time, a lot of money, data fixes, in production, issues going on in production, causing other things to fall out, then causing data fixes to occur. It's a mess. So they need to move that earlier in time. So we call it left shift. We're left shifting that, doing it earlier. All my projects have been doing this, on the build servers or on the developer's desktop, because that's what the kind of testing we do. But there are many hundreds of other teams that are not. And so it's a large shift in the organization. Regression testing. So when you have a suite of tests, so for those of you who don't do testing, when you have a suite of tests, any kind of testing, right? If you're not doing any kind of testing, seriously, you need to. It doesn't matter whether your organization lets you do it or not. You can write your tests on your own time, at home, whatever. Start to write tests. Because testing, when I interview a developer, at some point I'm going to ask him or her about unit testing. As in, I'll give them scenarios and see, like a business requirement, and see how they would test the scenario. And there, of course, most of them will say, but I don't know what the system is written like. I said, why does it matter? Who cares? You're testing the system that proposes that claims that it implements this feature. And this feature has all these requirements. So then how do you care? Test it. And that mindset gives you a lot of training. It's like it's molding your mind into thinking in a way that makes you actually a better developer. So you need to go through that exercise of saying, okay, now that I wrote this feature, how would I test it? Right? This feature has all these scenarios. What are those scenarios? How would I test it? Even if you go through the mental exercise, but of course, to ratify your mental exercise, you need to actually have physical tests. So you can ratify your mental exercise is worth doing. So I would say, just write tests. Don't worry about your team or your organization. right? These are excuses you're making. You can write tests. You can take out time, write the test. And the reason I'm saying that is with regression. So over a period of time, you have a battery of tests, a suite of tests that is now going to help you with regression. What is regression? If features are built into the system like 5 years ago and now you're building out new features, you want to make sure these regression tests will make sure that all the tests, all the features from the past are still working today the way they used to work back then. And as you add on a new feature, of course, you'll add a suite of tests for that feature. And then your regression test suite is growing, ensuring that the system is fully functional at all times, which is super, super important for the business. And it's super important for the sanity of the devs, because you probably had that experience where you had a new feature and something blows out somewhere else, right? You had no idea that this thing you did over here is going to have an effect like on some other end of the system. And generally you find these out in production, right? If you don't have a suite of regression tests. So that's what the business's biggest value is, this regression testing. That's all the business cares for. Okay, you did that, you fixed that, but you're sure that other thing is still working, right? Right. Now the no drift. As a kid, I don't know how old I was, but definitely a kid. And some of this is from my imagination, of course. So there was this book or a story called Gulliver's Travels. I don't know if you guys read that or went through that in school. And so my little brain was imagining this guy with these Lilliputs. Lilliputs were the smaller people. I don't know how small, but I imagine they're like that small. And he's strapped down on a beach or some place, and he's pinned down. These Lilliputs have pinned him down so that he can't move at all. To me, writing unit tests or a battery of or a suite of what I call acceptance tests, by the way, or unit tests, is you want to pin the system in places that it does not drift. There's not the slightest movement possible of the system. And any movement that does occur should blow out some test or tests, right? So that's what the no drift is. The writing a suite of unit tests, make sure your system is pinned in place, right? I mean, totally pinned in place. So then the slightest change will blow out a test. And if there's no drift, you're good, because then you're giving that confidence to yourself that nothing has ever changed. The littlest thing or movement in the system, something's going to blow out. So that's the value, right? All right. So the next slide is essentially, I think, makes the case for what I call acceptance testing. Most people call integration testing, as opposed to class level isolation, testing and isolation, right? Many years ago, this is a video, by the way, I do have a playlist on unit testing. There's at least 4 videos on it. I'll put a link over here. You can go watch it after this video. Please watch those, because in the very first video, I go into detail of what I'm going to tell you here now. But the whole playlist is important. And this video will be a part of that playlist as well. And any others I make will be a part of that playlist, because that's my unit testing playlist. So DHH, David Heinemeier Hansen, from the Ruby on Rails fame, many years ago now, I think 10 years ago approximately, blogged with the blog post title of TDD is dead, long live testing. And that sent shockwaves in the community. And next you know, he and Martin Fowler and Ken Beck are on a call, and that call, podcast, what you would call it, was posted on YouTube as, I think, 3 or 6 videos, like long, boring, many ways, videos. Boring only because this, like, nobody's answering the question. They're all just kind of, I don't know, meandering about, waffling off, here and there. Anyway, the crux of that was DHH was complaining that this TDD thing with all this mocking is just causing a mess. My life is miserable, blah, blah, blah. And both Ken Beck and Martin Fowler said this about mocking. So Ken Beck says, I don't use mocking, as in Ken Beck doesn't use mocking, and mocking is too high a price to pay. Just don't want to use mocking. Right? So Ken Beck doesn't use mocking. Martin Fowler says something like, there's nothing in the framework of TDD that says you have to use mocking. He says, and Martin Fowler says, I don't use mocking. So I do all my testing without mocking. And so DHH is wondering, okay, then like, so you see what I'm saying? Somebody says, this is what we should be doing, and he calls it TDD. So Ken Beck publishes a book in 2000 saying this is TDD. In 2000 and whatever, 15, let's say, I don't know what the year was. 15 years later, DHH is screaming murder saying, TDD is dead, long live testing. So what DHH is saying, I love testing, I just don't think TDD is the right way to do it. And indirectly, he was blaming mocking. All his problems were around mocking and the coupling that occurs with mocking. And so he made a big noise of it. And Ken Beck and Martin Fowler saying, we never said anything about TDD and mocking being coupled. We don't do mocking at all. Right? That was it. Anyway, Ken Beck's book says this. Refactoring shouldn't break tests. Now, what is refactoring? Just so we're on the same plane here. Requirements have not changed. You are simply refactoring, re-implementing technically, your design, changing classes, writing new classes, whatever you're doing, you're refactoring. Not because requirements have changed, because the requirements have not changed, but you're still redesigning, re-implementing your code to come back to the same set of requirements. Right? So refactoring shouldn't break tests. So if refactoring shouldn't break tests, how do you do that? So, this slide is more about, so if Ken Beck said all these things way back, in 2000, how do you pull that off with testing and isolation, right? Now, this was not something that drove me to what I call acceptance tests or integration testing. This is the slide I'm making a case for those who do testing and isolation to understand what was originally said in the book on TDD itself. And where I think things have just gone way off the tangent, and we should probably rethink our strategy here. So with isolated or testing classes in isolation, you can't pull this off because the slightest refactor, which means you added some classes, removed some classes, did something, your tests are broken because your tests are completely coupled to the classes. I'm not going to go into what mocking is and how you do it, but I'm hoping those of you who understand mocking know what I'm saying. Refactoring doesn't warrant writing new tests. Same thing. Just because you refactor the system, you don't need new tests. The requirements have not changed. No new tests. Refactoring may introduce new classes, but these classes don't need to be tested. Same thing. So effectively, all the bullets on this slide are essentially saying the same thing in different ways. What he's really saying is you shouldn't be testing in isolation because the test shouldn't know about implementation in the first place. That's effectively what all these bullet points are saying, and that's how I do my testing. My testing is where I don't know what classes are inside the system, and we'll get to that in the next slides. Adding a class is not a signal for writing a new test, etc., etc. Test cases and tests should pass no matter what the design ends up being, right? So these are all what Ken Beck said in his book, and I totally agree. Now, before we move on to the next slide, I want to talk a little bit about TDD. I don't subscribe to TDD, so obviously that's not a shock. I do understand and in many ways subscribe to what Ken Beck is saying in that book, but I just don't subscribe to the idea of TDD. All right, and I'll explain why. And Ken Beck actually makes a point for this in his books. I'm still not sure how he kind of justifies TDD. When I'm designing and implementing a system, for production, my mindset is completely production oriented. I'm thinking about so many other concerns about, production, performance, resiliency, scaling, all kinds of things when I'm designing and implementing the code. I'm not worried about testing. It's a completely different mindset. And when I come to testing, I'm not thinking about performance and resiliency and this and that. I'm just thinking about testing. To me, these are very different mindsets. You're wearing different hats. And Ken Beck actually says that. Ken Beck says in his book, don't write the tests now. So he's saying that when you're implementing the code, you're wearing a different hat. You're wearing the designer's hat or the implementer's hat. You should write the test a day or so later, where you wear the tester's hat. So he recognizes that whole thing. He doesn't call it TDD as most people say, write the class test first, then write the implementation. And all. That's not what he says. So that's why I'm saying I don't do TDD at all. I write the system. The features implement, everything's working. We know the system is working as the way we expected with regards to our manual kind of testing as we're developing, right? And then the tests come along, and then we'll assert all the requirements, all the scenarios, and make sure our system does what it's supposed to do. By that point, we're focused completely on testing, right? And if during that testing we find there's a bug, of course we'll fix it, but we have to make sure that we're testing it correctly before we say it's a bug in the system, right? So the next slide here is, think of this as my system, this dotted line, black box as my system. Most of you have seen this slide before. And the idea is that this system is talking to external services, databases, message brokers, services, etc. These could be your services or third-party services outside the company or whatever. And the service and base layer. So I want to talk about sort of the strategy I employ, right? You got a system like this. Generally speaking, let's say in this case, it's a ASP.NET application. So it's got the middleware, controllers, exception handling going on here. So this code you're writing here, this code you're writing here, and all this code is that you're writing. And then you got a system that talks to a database, message broker, services, one or more services, and maybe one or more services are external or third-party services. Okay, so Roy Osherove, in his recent interview, the one I'm hopefully going to put a link down in the show notes below for you guys to see, it basically mentions the same thing. So the idea is that when you're leaving your system boundaries, so here's that system boundary. That's why I put this dotted line. This is the boundary. And when you leave this boundary, these are areas where you potentially use some form of a test double. A test double is the generalized term for things like mocks and stubs and fakes and spies and all, what have you, right? If there were a taxonomy, then test doubles would be like on the top, and then these others would be below that. I don't actually do even that. As in, if it's my services, I don't use test doubles and kind of replace that boundary. I use the real class. I need to test my system. So I need to test real. If it's my database, I'll use the real database. I'm not going to sit and use a test double to kind of somehow mock, fake, stub, whatever my database. I need to use my database. It's got stored blocks in there. I need to test those. So the only time I might use a test double is one, if there's a third-party system that doesn't have, let's call it, the facilities that allow me to test it. And maybe I can't send it junk data because it's only a production system for them. So I can't send it crap, right? It's like a credit card service. If they don't have a testing endpoint, I can't test it with some real credit card. I don't want to transact my real credit card, right? And such like that. So if there are facilities that the third-party service does not support, for those tests, I will insert a test double in the pathway. But for anything else, I'll use the real thing. So I'm going to use the real thing as far as I possibly can, because I'm more interested in testing as much as of the actual code that's going to go to production than just making my test pass. That's not the focus. The focus is make sure all the code that's going to production is being tested, right? Roy Osherove says the seams or the boundaries is where he uses test doubles. It's not like a forced thing. I don't use test doubles, but if I do, it's going to be there, right? And that's all. There's going to be a test double only in the boundaries, the parts that leave the system, nowhere else in the system. So let's look at the strategy now for testing. So the first suite of tests that I write for my systems is for the acceptance tests. These are, some people call them integration tests, but I have a different idea of integration testing, which you can see here, end-to-end integration testing. So I call it end-to-end integration testing just to kind of use a different vocabulary from integration testing. For me, acceptance tests are tests that the business will, if you say all these acceptance tests are passing, and the business, and I'm just loosely speaking, the business gives you the requirements. From that, generally the business analyst will derive the scenarios that you need to test. If you don't have such a thing, you're going to have to come up with it. So no matter how it came about, these acceptance tests are testing the business requirements and every scenario of each of those business requirements. That's the acceptance tests. They test the system, meaning from the domain facade on, from this domain facade, from here to the end. Right? So testing from the domain facade all the way through without concern for what's inside. So they're integration tests in that sense, as in it's testing, talking to databases, sending out messages, it's talking to services, all that's happening. Okay. The next kind of test we write would be controller tests for like Web API or ASP.NET applications. These controller tests are tests that take the controller class as a class, new it up, call a method, send it the arguments, and you get back what you're supposed to get back, and you assert and make sure that's happening. But when you're testing the controller, you essentially have a stub for the domain layer, because you're not trying to test the domain layer again. You're only testing the controller, which means if the domain layer were to send it some response, what is the controller doing with that? If the controller sent it some data, and from that data came back some sort of a response, what would happen, right? Just the controller. And controllers generally do very little, maybe 1 or 2 lines of code. And at least in my controllers, that's what we have. We don't write code in controllers. The controllers simply do mapping and then make calls to the domain. So we sort of use a test double, use a test double to kind of pretend that that's the domain layer. And we make sure we arrange for certain responses and see how the controller reacts to those things. Now, one of the things, like from a drift point of view, controllers in my world don't catch any exceptions because we have an exception handling middleware, which means if a controller caught the exception, it won't come there. But really, we want all exceptions to come here so that this exception handling middleware is going to handle all exceptions in a uniform fashion. And all our consumers would see the same style, if you will, of exceptions translated from from C# to HTTP in a uniform fashion. So all exceptions look consistent. Which means in order to ensure, so let's say I'm a new dev on the team, and I come in and say, what, these guys don't have exceptions in the controller? Are they kidding me? Seriously? He starts putting, I start putting try catches or try catches in my controllers, and a test should break when that happens, because that's not supposed to be done. And so we have tests. That's what I mean by drift. You follow? In the few slides prior to this, I was saying we have this idea of drift. Any change that could impact kind of your system's behavior, make it have a different behavior, you need to have a test for that. So we actually have in our controller tests where the test double for the domain side will throw an exception, and in our unit tests, we will see and ensure that we get an exception, not a caught exception, like not something that caught that exception, so that we can ensure that at no time does anyone attempt to write a try catch in a controller. And so think of that. There's many other tests like that are more, those are the internal value kinds of tests, right? The business value test and the internal value test. So that's what I was talking about there. And the final, no, it's not final, but the third, there's actually a fourth category, but there's this third category here, the end-to-end integration tests. These are testing, because we have middleware here now, that's not been tested ever, right? And then the controllers, even though they couldn't have been tested, the controllers have like an endpoint, a URL. And if somebody inadvertently changes the URL, that's a breaking change. You need to have tests for that. In other words, we need to, the end-to-end integration tests are spinning up the application as a website and using HTTP during your testing to call endpoints to make sure that those endpoints exist, they're valid. And if you send this form of HTTP to those endpoints, it gets converted correctly to some C# type and doesn't blow out and things of that nature. We're not trying to test the domain layer, even though the arrow kind of goes from here to here. The entire system is at play. The entire system is at play. There are no test doubles. But the extent to which we do those tests are to test endpoints, make sure exceptions are coming back correctly, being handled by the middleware, and being translated correctly, and such. No major suite of tests. There's a suite of tests, of course, for end-to-end integration testing, but it's not testing the full out functionality of the business system. That's been tested by acceptance tests, right? So the end-to-end integration tests are also integration tests, but they're testing things that we could not have tested without having done those tests. I also have class level tests. I call them class tests. So these are not unit tests, they're class tests. Generally, there are class composites. So they're a composition of classes. It's not just one class, but either ways, it's a class or a class composite test. And we do that for generally as a suite of composite of classes that implements a feature of functionality that is critical to the business and or complex or both. Critical and or complex. Critical to the business and or complex. And we decide as a team, man, the thing is just super complicated or super important. Should we just not have a suite of tests for that composite of classes? I mean, if you have a class that's complex, that's a little weird, right? It's a class composite. So that's doable and it's possible. It happens every once in a while. It's not a requirement. Like you not must have this and must have that. But if the team decides, hey, that thing is like way too complicated, maybe you should just have a suite of tests because, and that's the value for that is, and I've done this in the past, is if you have a suite of tests for that complex business, let's say business rules feature that composite of classes is implementing, you have the benefit of being able to refactor it over time. But with those suite of tests, with the class composite tests, ensuring that your refactor is still on track, meaning you haven't changed or modified or broken anything since the previous time, right? And in fact, that's what I did in the past was I inherited one of those systems and they had this really complicated thing. And it not only was it complicated, it was a mess in terms of implementation. So the first thing I did was write a suite of what I call class composite tests today that I'm going to first write these tests because the system is working. It's just every time somebody went in to add some features, something else was breaking out. It was a nightmare to make changes to that portion of the system. And so I wrote a suite of tests, tested all the rules that I knew, working with the analysts, the business analysts, and getting all the rules and I implemented the tests for that. Took months. And once we had that suite of tests, now that we have a suite of tests that tests every feature, and we sat with the business analysts and we made sure that we have accounted for every scenario of every feature. Great. Now we can throw away that and re-implement it in a much better, cleaner, more approachable, more maintainable manner. And we did. But we had the test to help us with that, to ensure that we are still on track, right? And that's the value of writing these tests. So don't think you have to write a whole suite of tests from the get-go. You can start writing small tests or targeted tests for parts of your system to give you like a sanity check. And then over a period of time, you yourself or your teams will start to, add on more and more tests. And then eventually at some point you got to say, okay, you know what? We've been writing tests. Let's just make this official and let's make sure we're doing good testing, good testing habits, good testing culture, et cetera, et cetera. So, but start somewhere. Testing is super, super hard. I mean, seriously, it is super hard. I think that's some of the reasons people don't do testing. By hard, I don't mean the code is complicated, and I'm not talking about mocking because the code gets super complicated, with all the delegates and the funcs and all that going on there. My tests, as you can see, the code here it's the same code you write in production, right? And that's the other thing I love about this testing. It's the same code. It doesn't look different. It doesn't look funky. It's the same code, same style, if you will. The reason it's hard is that how to, what to, and how to arrange for the scenario is super complicated, super hard. By that, again, I don't mean it's hard to do. It's what should I do? What should it be? Thinking about all of those things. And if I did this, does it even make a difference? Does it even matter? What if I just made the data slightly different? Does that have a meaning or an impact? Should I have the data this way or that way? That's the hard part. Right? To think about, you're arranging for data, but are you arranging the right data? Should you have one more record that has got a slightly, slight tweak like that? Because that's the true way to test all the these features. That's the hard part. And then the assertion, how to assert, what to assert. By how to, I mean, when I get a response, if I assert this and this, is that the right assertion? Or should I be asserting this, and the other thing? Like, what's the right assertion to do? That is the difficult part. I find this super interesting, not because it's interesting, it's hard, I guess. I gravitate towards these challenging kinds of things. And it exercises your mind to no end. It's like there are days when, you spend a lot of time just doing testing, or we're having discussions and, with the team, and there's one person that's got tasked with this one task to do, and we're all sort of adding our, 2 bits to his or her effort. And it gets so complicated, but just so interesting. Everyone's glued and focused on this conversation, except you kind of get mentally totally drained by the end of it. I call it, my brain's fried. And this is one of the few times my brain gets fried. Very few. I mean, I normally don't have any, I can go on all day long and I'm still like there. All my 12 cylinders are firing. But sometimes it's super hard. So anyway, if I haven't convinced you to, or I'm hoping that I have convinced you to start testing in some form or fashion. Step 1. For those of you who are doing testing in isolation using mocking and various other things, I'm hoping that I have encouraged you to at least look at the movie service project, give it a good look over, really dig deep into it, understand what it's doing, how we're doing its things. And if you find a problem, or if you think there's an issue, I'm happy to have a dialogue. You can write a comment. We can have a dialogue. I'm totally open to hearing some valuable stuff. I mean, as I said, this has evolved over years, and anyway, I'm open to ideas, or open to something you find. If I think that's really a problem, then certainly it might help me fix or improve, something I'm already doing. So this brings me to the end of this video. I hope you've enjoyed yourselves. I hope you learned a few things. If you have, please give me a thumbs up, and I'll see you next time.